Hello, my student, and how are you doing? Good. I'm very sure you're okay. Personally, I'm doing well. Now, in my previous video, I did post a question paper. I did post a full paper one. And my expectation is that you went through the paper, you challenged yourself through the questions, and you're very much eager to see the answers. So what I'm going to do in my next video, or rather in the very same video you're watching, is to post the answers, including the discussion. So we're going to discuss the questions I gave you. So pay attention, follow, stop the video, and try as much as possible to understand as I explain. And kindly watch the video to the end, because I have a very important message at the end of this video. Good. Question 1 was a question on Bunsen burner, the part labeled A. This is a non-luminous flame, so the part labeled A, the outermost part, is the pale blue zone. Otherwise, part B is the almost colorless zone, which is also called the unburnt gases. Question B, the function of part C, that's the air hole. That is, the function of the air hole is to control the amount of air entering the chimney. So it closes and opens the air hole. Question 2. Question 2, you are to complete the nuclear reaction. As you can see, the mass number has not changed. 210 minus 210 is 0. Then the atomic number changes from 83 to 84. And that means there is a particle being released with a -1, the atomic number. So the particle with the atomic number -1 and the mass of 0, that's a beta particle. That's a particle that is missing. So it's a special electron. Part B of the question, you're given that the half-life was 5 days. So there are two ways you can approach this question. The initial amount was 100 grams. Then the amount decayed for 20 days. First of all, you can use the formula that the remaining amount will always be given by 0.5, or rather half, raised to power n multiplied by the initial amount. The n here is the total time divided by the half-life of the material. If we do that, 20 divided by 5, you're going to get 4. So 0.5 raised to power 4, yeah, that's a power. The 4 there is a power multiplied by 100. You get that the remaining amount of the radioisotope X will be 6.25 grams. Remember, you can do step by step method. You state that 100 grams, when it decays for 5 days, that's the half-life, it becomes 50. Then the 50 undergoes a decay again for 5 days, it remains 25. Just like that, after the 20 days are exhausted, that is 4 half-lives, that is 4 times 5, the remaining amount will be 6.25 grams again. With part C, the dangers associated with radioisotopes. The radioisotopes are basically the main causes of cancer. They can also cause what we call gene mutation. They can also kill some living cells. It can also cause some deformities to the unborn, among other dangers of radiations. Question 3, you're given the structure as the question had stated. The type of structure is metallic. So, or rather, then it's a metallic structure with metallic bonding. So, part B, this is a group 1 metal, because if you look at the structure, it has a negative. Each particle has a -1. That is 1 electron. So it's a monovalent metal. So it's in group 1. Okay, with question number 4, you're asked to select the element that will protect iron from rusting. The electrode potential of iron to iron metal is -0.44. Now, for the metal to qualify to be a protector, like with sacrificial protection, it must be more reactive than iron. And the more reactive, it means that metal must be a stronger reducing agent. And the most negative, the element with the most negative electrode potential, it is the best protector. It is the best that can protect. It is the most reactive. For that case, R is the metal that can best protect iron from rusting. With the question part B, you are supposed to calculate the EMF of the cell given. With that, you have two methods. You can use the formula that the EMF of the cell can be given by the electrode potential of the reduction process, or the process taking place at the cathode, subtract the electrode potential taking place at the anode, or the oxidation. And with that, 0.86 subtract the negative 0.14, you get 1.00 volts. Alternatively, you can identify the process. You can identify out of the two processes, the one that is undergoing reduction, then the one that is undergoing oxidation. Remember, the one with the most negative, it is the metal that has the highest tendency. That one, it is the metal that has the highest tendency to gain electrons. So with this one, S will gain electrons while P will lose electrons. So you reverse the equation. Like this one are reduction potentials. So you reverse the one, the half cell equation for P, so that it will look like now an oxidation process. Then you add the two, and you can see exactly what has happened with method 2. Then question number 5, you're given a polymer. Remember, if you look at it keenly, these are repetition of 2 units of or 2 monomers, because they are very identical. So the name of the polymer is polyphenyl. We call it polyphenyl ethene. When you have the benzene ring attached to an alkyl chain, we call it phenyl. Otherwise, the common name is polystyrene. If you ask to draw the monomer, this one is as a result of additional polymerization. With additional polymerization, it is the alkenes that opens up the bond. So what you need to do is to close the bond, and you get now the carbon-carbon double bond, and of course the rest of the part there. So it is a phenyl ethene that is repeating itself. Then with part C, you're supposed to name just to state one use of polystyrene. So polystyrene is a good insulating material. You can have it in form of, it can make packing materials, just to pack items. Very many disposable plastic cutleries, they are made of polystyrene. They can also be used to make ceiling tiles. You can also use them for many other plastics that are of economical use. Good, we go to question number 6. Question number 6, the part C, the hump you see there, part C, it represents the activated, or what you call the intermediate complex for, of course, the uncatalyzed reaction. Then we have part B of the same. You asked to state how does a catalyst increase the rate of reaction. If you look at the diagram, you'll notice that the uncatalyzed reaction has a bigger or larger activation energy. So the catalyst lowers the activation energy, and therefore the reactants can have more effective collisions because they have less energy. Question number 7. Question number 7, it's a calculation question based from the information you're given. So what you need to do, like in this case, calculate the number of moles of barium chloride. And this one, as calculated here, it is 0.6. Go ahead and calculate the number of moles of copper 2 sulfate. With copper 2 sulfate, the number of moles is 0.9. With that, bearing in mind the mole ratio is 1:1 for the two, copper 2 sulfate and barium chloride, it means copper 2 sulfate was in excess. That tells you barium chloride is a limiting reagent. The number of moles of barium chloride is what we're going to use for all our calculations. With that, now from the thermochemical equation, you can realize that 1 mole of barium chloride gives us 17.7 kilojoules of energy. And that tells you with 0.6 moles of barium chloride, the amount of energy they'll give us, it is 10.62 kilojoules. Otherwise, you can convert that to 10,620 joules. Remember the formula for enthalpy change. It is the mass of the solution multiplied by the heat specific heat capacity multiplied by the change in temperature. So with that, the total mass we are using it is the 600 grams added to 900 grams. Remember, now we have used the density to convert the centimeters cubed, the volumes, both volumes, to mass. With that, we have 1500 grams. You subtract, you multiply 4.2 kilojoules or joules per gram per Kelvin, then times the delta T, which we don't know, and that will give us 10,620. So with that, if you go ahead and do the calculations, you realize that the heat change, the temperature change for this reaction was 1.69 that was 1.69 Kelvin, which is equivalent to degrees Celsius, because we are working with the delta T, change in temperature. The units are the same. Question number 8. The data as given before in the question, then the sample that is likely to be soft water is the sample number 2. Why sample number 2? Because it required very little amount of soap to form lather, and in addition, even after boiling the water, the amount of soap required to form lather remained the same. So the question part B, why was, we are supposed to explain why in sample number 3, if you consider what has happened, the amount of soap required has changed from 8.5 centimeters cubed to 2 after boiling the water, and that tells you this water had temporary water hardness that was removed by simply boiling the water. And once the water was boiled, then less soap was required to form lather, and that is the basic explanation for that. Question number 9, the setup as it was given. Then you have to write 2 chemical questions that are taking place inside the combustion tube. The first question, carbon is reacting with oxygen, excess of oxygen to give you carbon oxide. The equation should be as you have written. Then carbon can also react with oxygen. Remember, this is an enclosure. The amount of oxygen may diminish with the time, so the limited oxygen may make it possible for carbon oxide to be produced as per equation 2. Equation 3, the carbon oxide is a very unstable gas, so it can as well react with oxygen to form carbon oxide. The iron 3 oxide can be reduced by carbon oxide to form iron metal, and carbon oxide is also produced. Number 10, you're given the table, the data you are to complete. The number of protons, it is exactly what is written as a subscript down there. It is 24, the atomic number. Then the number of neutrons, remember it is the mass number, you subtract the protons. 52 subtract 24, you get 28. And with the number of electrons, you'll be guided by the charge. Initially, the number of protons and electrons were equal in an atom. But in this case, with 3 positive, it means the particle lost 3 electrons. So with that, it will be 24 subtract 3 to get 21. That's question number 10. Question number 11, for that matter, it is the fractional distillation, the operator X, that is a fractionating column. Then the operators Y, it is the condenser or the Liebig's condenser. The liquid Z, that is methanol. Considering that there's still some amount in the flask, that's the round bottomed flask, that must be the first distillate to come out. Methanol with a boiling point of 65. Question number 12. Question number 12, you are calculating the oxidation state of sulfur in the compounds given. With that, it is you assume that what you're working out, the oxidation state, is X. With that, then you add with hydrogen, the oxidation number is +1. As you work it out, +1 multiplied by 2, because there are 2 in the formula, add X, you get 0, the overall charge. Then finally, the oxidation state of sulfur is -2. With the sodium thiosulfate, the same working. Sodium being a group 1, it has a +1, multiply by 2 because there are 2 sodium in the formula. then add 2x, that is sulfur. There are 2 in the formula, multiplied by x, its oxidation state. Of course, you add 3 into -2. Why -2? The oxidation state of oxygen equals to the overall charge of 0. As you work it out, as depicted in the working, the oxidation state of sulfur becomes 2, +2. Question number 13. Question number 13, the extraction of zinc. Question part A, the ores of zinc. The zinc blend, that is zinc sulfide, then the calamine, zinc carbonate. Remember, with ore, these are impure substances, these are mixtures. Sometimes you are discouraged from writing the formulae because it's not a pure substance as such. In unit 2, zinc oxide is being reduced by carbon to form zinc and CO2, or CO. It can also be the carbon 2 oxide. And the zinc oxide can also be reduced by the carbon 2 oxide to form zinc and carbon 4 oxide. Remember, the carbon and carbon 2 oxide, they are very good reducing agents of the metals and lowering the reactivity series. Question C, the uses of zinc. It can be used to galvanize iron to protect it from rusting. Otherwise, it's called cathodic protection of iron. Then it can be used to make brass, an alloy of zinc and copper. It can also be used to make outer casing of the dry cells. So among other uses of zinc. But you require just to give 2. Question number 14, Charles law. CP, that means Charles law, pressure is always constant. With that, it is said the volume of a fixed mass of a gas is directly proportional to its absolute temperature. Remember, the word absolute is key here. Absolute temperature when pressure is kept constant. Then part B is the application. The application of this, if you look at the question details well, the pressure is constant. So with the formula, we're not going to include pressure. It is the volume 1 divided by temperature 1 will give you volume 2 for case 2 over temperature 2. And if you substitute your values and you work out the value of T2, it will be 232.8 Kelvin. That is the temperature. Remember, in the question, they have given us the temperature in Kelvin. We don't need to convert to degrees Celsius, because if you're to convert to degrees Celsius, you'll have to subtract the constant 273. But for now, you leave it as such. Question number 15. The general formula that you're given, that is an alkano. If you look at it, that's an alkano homologous series. So the third member of the alkano series is propanol. Propanol. The structure of propanol, as it's given with open bonding, it is 3 carbons bonded to hydrogen all around with an OH somewhere. So that is propan 1O. Part B. That is part B. You're to give the complete combustion of propanol. And propanol, when you burn it, it reacts with 9 moles of oxygen to give you 6 moles of CO. Question number 16 on periodic table. The first thing you're asked to do is to write down the electron arrangement of the most stable ion of V. Remember, V is atomic number 13, just judging from its position in the periodic table. So with that, V will be stable by losing 3 electrons to assume the neon electron arrangement, that is 2,8. The equation for the reaction between T and W, at the back of your mind, you should know T is magnesium and W is nitrogen. So you can write the equation as they are given. 3 moles of T requires 1 mole of W, and W being nitrogen, it's diatomic to form T, the W, the way it is. And if you go ahead to identify the elements as they are in the real periodic table, that is magnesium and nitrogen, the equation will still be correct if well balanced. For part C, the ionization energy of N and M, you're supposed to compare. With this, M has a larger atomic radius, and that tells you M has a lower ionization energy. The way the radius and the ionization energy are connected is that if an atom, a metallic atom, is larger, it means the outermost electrons are very far from the nucleus. And that tells you the effective force of attraction between the outermost electron and the nucleus is minimal. So the larger the atom, the lower the ionization energy, and vice versa. You can argue the same case with nitrogen. Not nitrogen as such, N, letter N. Remember here, the letters do not represent the actual symbol. Okay, question number 17. The part A, you have to give the meaning of an acidic solution. An acidic solution is a solution that when dissolved in water, it releases hydrogen ions as the only positively charged ions. Otherwise, it dissociates in water to form hydrogen ions. The ionic equation for the reaction between lead-2 nitrate and what we call the carbonic acid, it is the lead-2 ions from the salt combining with the carbonate from the carbonic acid to get the insoluble lead-2 carbonate. The equation is given. Number 18, you are to name the processes. Iodine changing directly from solid to gas, that is sublimation. Ion 2 becoming ion 3, that's oxidation. Remember, oxidation is the loss of electron. When the charge increases from positive 2 to positive 3, it means the particle has lost electron. That's oxidation. When sugar is subjected to a concentrated sulfuric 6 acid, it undergoes dehydration. Question number 19. The unknown carbonate, Q carbonate, is there. Then you're given that the 1 gram of that carbonate react with 20 centimeters cubed of 1 molar HCl. So the way to work out that, first of all, work out the moles of HCl. 20 multiplied by 1 divided by 1000. You get 0.02 moles. So according to the mole ratio, every 1 mole of the carbonate react with 2 moles of the acid. So if you to work out the number of moles of the carbonate, it is half the number of moles of the acid. So you divide 0.02 divided by 2. And with that, if I want to get the molar mass of the carbonate, I will divide the mass given, divide by the number of moles. Otherwise, you can still use the first principle. You use the first principle and it will be fine. Because you're going to argue out if 0.01 moles is equivalent to 1 grams, what about 1,000? Then out of the carbonate given, you know how to work out the relative mass of the carbonate. So with that, it is 12 plus 48. You get 60. So the unknown Q, you can have that equation Q plus 60 get to 100. So the value of Q is basically 40. Question number 20. The element that is a liquid at room temperature, that's bromine. The reason for that, the melting point, that element will melt at a temperature below 25 and boils at a temperature above 25. So at room temperature, it will be a liquid. Then you explain why iodine has a higher melting or boiling point. The boiling point of molecular substances is connected to the size of the molecule. And with that, iodine has larger molecules. And that is the van der Waals forces are holding the molecules together are stronger in iodine compared to chlorine. And therefore, higher or large amount of heat is required to break the van der Waals forces in iodine. Okay, with the question number 21, you're given the bond energies. So you only need to work out the bond breaking energy. And you're going to consider all the types of bonds that have to be broken before this reaction takes place. The carbon-carbon double bond, the carbon-hydrogen bonds, the 4 of them in ethene, and the hydrogen-hydrogen bond on the reactant side. When you add that, you get 2,703 kilojoules. With bond formation, now on the product side, it is just one product, ethene, And with ethene, now the ethene with E, it is a carbon-carbon single bond has been formed, then 6 carbon-hydrogen bonds. If you consider that and multiply 6 now, like with the bond energy, for that you get 28, 27 kilojoules. Then the net heat, the total heat energy, it will be the heat as a result of bond breaking, then subtract, or you should add the bond formation. Remember, bond, what we call the bond of breaking is endothermic, and bond formation is exothermic. So if you consider that and you subtract, or rather you add, actually you are adding, because the positive sign you see on the final step here, it is the negative plus negative. That's the negative negative to get the positive. And finally you get the net heat change of 124 kilojoules. That is kilojoules per mole. And the negative sign is to show that it is exothermic. Question number 22. For the thermochemical equation you're given, the information with the negative, it shows the reaction is exothermic. Some heat are given to the surrounding. Then with part B, the catalyst that we need, it is vanadium 4 oxide, or rather 5 oxide, what we call vanadium pentoxide. Platinum can also work. Question number 23, we are describing how we can make magnesium hydroxide from magnesium oxide. The first thing to do is to add excess of magnesium oxide to a given dilute acid when warm, just to speed up the reaction, and you can stir. Then you filter out the unreacted magnesium hydroxide. Remember, now you have a filtrate, that is magnesium hydroxide. Magnesium, not magnesium hydroxide, it will be magnesium salt, magnesium nitrate, magnesium chloride, or magnesium sulfate. Then with the magnesium sulfate, you precipitate out the hydroxide using either sodium hydroxide, potassium hydroxide, or aqueous ammonia. It will precipitate out the hydroxide. Then you will filter out the hydroxide, that is magnesium hydroxide, and you dry using some filter paper, or in an oven, or you can filter by sun drying. Why should you do that? Magnesium hydroxide, when you heat it, especially strongly, it can also decompose. One use of magnesium hydroxide, it's a good antacid, because it's an alkaline, a weak base, so it can be a good anti-acid medicine. Okay, so we can also use it to make toothpaste. Question number 24. You're given that electrolytic process, the observations, like the 3 observations: the bulb will light, the reason being molten lead bromide will conduct electricity because of the free ions in it. Then the bulb lights. Then there will be a red brown vapor at the anode, that is the bromide ions being discharged. They are undergoing what we call oxidation to form bromine gas. Gray solids are formed at the cathode, that is the lead ions being what you could say, they are being reduced to lead to metal, that is gray. Question number 25. Ammonium nitrate, when heated, the gas that is evolved is nitrogen gas. That is nitrogen gas. You should go to the book and get the chemical equation for that. Then we state why heating should be stopped. What should be done before you stop heating? Good, the derivative should be withdrawn. Once you withdraw the derivative, you are preventing what we call the sucking back of water. Because if you allow the apparatus to cool, the partial vacuum that is created will create a suction that will suck in the water. So that may cause the tube to crack because it's already hot. Question number 26. You have the equation on propane. Propane, the equation, the thermochemical equation was given, and then now we are supposed to calculate the volume of propane that gives us 1,000 kilojoules of heat. From that equation, it means 1 mole of propane, when burnt, it gives us 2,220 kilojoules. So if that is the case, then you need to ask yourself, with that case, what volume, or what amount of propane will give us 1,000. You divide 1,000 by the 1220 to get the number of moles of propane that will give us that amount of heat. With that you get 0.45045 moles. And if that is the number of moles, we need to convert that to volume by multiplying by the molar gas volume, 24, to get 10.81 liters. The question was, we draw the structure of propane. Propane is an alkyne, so it has a triple bond, carbon, triple bond somewhere. Then with 3 carbon as I have drawn there. Remember, for a structure, you need to do the open bond. Question number 27, you're trying to precipitate out copper 2 ions using aqueous ammonia. So if you do with aqueous ammonia a few drops, copper 2 hydroxide will be formed, which is insoluble, which is that's the blue precipitate. With that, the deep blue, if you continue adding, a complex is formed. The complex, we call it tetraamine copper 2 ion. The formula, otherwise it's there. With number 28, hydrocarbon, wax is just a hydrocarbon. When burnt, it gives us water and CO2. So the first product being collected in the YouTube is water. If they say identify, you can as well do a formula, H2O. It is acceptable. You describe how the other product can be prevented from getting into the environment. That one, we can pass it over an alkaline solution, be it potassium hydroxide, be it sodium hydroxide, or aqueous ammonia. Remember, the second product is carbon monoxide gas. This alkaline, if there's something you need to know, alkaline solutions have good ability to absorb carbon monoxide. Then question number 29, and the last one, elements that show allotropy or exhibits allotropy. We have sulfur, as far as high school concept is concerned. Remember, phosphorus, tin, sometimes say oxygen, it's also acceptable, but in high school maybe we don't mention. Part B of the same, why is graphite good for making lead pencils? Remember, graphite, in the structure, it is made of hexagonal layers that are held together by weak van der Waals forces, so that allow them to slide over each other, and when compressed, it can easily be done. That is the end of the 29 questions for this paper. Thank you so much for following, and you can replay again just in case you did not understand. Kindly leave your comment here and recommend to a student. Can you recommend this site to a student? And tell them to subscribe, like, comment, and even recommend to other students. Otherwise, you can go ahead and listen to the message I promised to give to you. So thank you so much for watching, and I promised a very important message. My message is this: I want us we start interacting now. I know I've been posting videos, and from the other side, I don't know whether you've been watching, whether you have been getting some hope from my videos, and that's why I want us to start interacting. And this first of all goes to the students. If you've been watching and you have a comment you like to say verbally or visually, you want us to see you, so I'm giving you an opportunity. You can send me like a 30-second video. You can just record yourself, or rather take a clip of yourself and send me your comments. Send me a message you want to pass even to other students pertaining chemistry. Maybe you are a student who is doing very well in chemistry. You have some secrets. You have the idea you want to pass to students what you've been doing. Kindly take a short clip, like 30 seconds there to 1 minute at most. Then you send that clip to the number, to my WhatsApp number that I've given down there, and I'm going to include the clip you've sent me to my next video that will encourage very many students who follows my page, and I'll be very much glad to see you do that. So maybe you're also a very talented chemistry student. You would like even to share with us what you'd like to become, maybe a career that is connected to chemistry. So kindly post that for us. And maybe to the rest of my good friends who are not necessarily students, and you are my good followers, I have two issues to address, or to bring to your attention. One, you can also record yourself. Let me hear what you have, and also send to the WhatsApp number that I've posted there. So record yourself, any recommendation, any good words to encourage me, keep on. Kindly let me hear it. The second thing, there is an opportunity for us to touch life. That is to help a student. We were once students. Maybe at one point a person assisted us, paid our school fees, sponsored us, bought a book for us, bought a uniform for us. So I'm also going to give opportunity that we touch lives. By that I mean, as a teacher, I know of many students who are struggling with school fees, with basic needs. So we are going to use this platform, and we are going to identify the very needy students. And remember, most of the needy students are very hardworking. They are very bright students. They have a future. So by that I mean, we are going to identify students, and I'm going to help you because I'm in the education field already, and I'm on the field. I'll be able to identify students who are very needy. Maybe some need very basic things. So we are going to come hand in hand, and we sponsor some of the students with basic needs, be it even paying their school fees. I know it's very much possible. So for those of us who are not students, kindly let's bear in mind, I have that issue in mind, because I know of many students who are bright and they do not have people to sponsor them with very little things. And by that, we'll be able to touch a life. We'll be able to encourage a student somewhere, and that student is able to achieve his or her dreams. So otherwise, be passionate, or rather be people of goodwill, and I know we're going to do great things. If you're such a person, and I know you're there, you like to support a student, let me also know, and I'll be glad to even connect you. Thank you so much, and continue following the Dr. Sirme YouTube channel. God bless you.